Hello, YouTube learners, students, and friends. Once again, this is Dr. Satish Singhal, PhD, Professor of Computer Science at El Camino College, Torrance, California. So, this is the last of the series of 4 videos. In this one, I'm going to show you C source code and use of array to convert hexadecimal to decimal. This is the video 404. Please watch video 1, 2, and 3 before watching this, otherwise you may get confused and it may not work for you. So for this part, we directly go to our source code in Xcode and demo the algorithm that we did in video number 3. And we'll point out some of the steps of the algorithm. Again, that's our source code in C. So basically the includes I'm going to need will be stdio.h, string.h, because hex number is saved into a array of characters string, C type H. I think that's for the 2 upper, and math.h for the getting the power. So I create array of capacity 20. The reason I have 2 of these, convert hex to decimal and the version 2, because I actually do have 2 versions, and today I'm only going to demo this one. So main function is pretty simple. I have flag control loop here. I call the function, this one that I'm going to discuss, and function basically asks you to input a hex number and goes through the algorithm that I discussed in video 3, converts that to decimal and prints it, and then user can do the next number or number after that, and if they want to stop, they can enter 0 to continue, 1 to stop. The reason we need to do get char, because in this function we use fgets, and when we enter value of done, a character is left in the stream, and we need to remove that if we're going to use this function again. Okay, so let's go to this function. It's right here. So there was a pound define done capacity 20. That would mean that I can convert a hex number that could have up to 19 digits, because actually more like 18, because 2 spaces are required, one for the null terminator, one for the end of the line character. So up to 18 digits. Okay, so we create an array of size 20, which will be storing our hex number, and these are used later, result and the digit. Digit would be each digit in the hex number, which got converted to int. We had the algorithm for that. And result will be sum of the contribution from all the digits. And I declare a len, which I'm going to use a little bit later. So I ask the user to enter the hexadecimal number, and I use the fgets. I have another video on fgets, you can watch that. And fgets store user input into this array, and its size was capacity. Capacity minus 1 is required because one last character is a null terminator, and we need to leave room for that. stdin means I'm entering the data from the keyboard. So now, in order to iterate through this array of characters, which has hexadecimal number in it, I need its length, and length is of a array of characters or a string, C string, is gotten by a function called strlen. So I pass it the array, and strlen returns its length. Length is in size t. My len was int. If I leave it that way, compiler will scream at me that, hey, this was size t, this is int, you're losing precision or whatever. So I cast it to int type. Okay. So now I don't want to count the end of the line character I showed you in the previous video. F gets the user entered string, but it's also tacks on end of the line character for that, which is not part of the hex digit, hex number. So I need to ignore that. So next is that I want to convert any letters that by mistake user might have entered as lowercase to the uppercase, because that's how I'm going to convert them actually. So I iterate through my array from 0 to len minus 1, because actually this will be len minus 2, because len minus 1 is my slash n, this one. And I use the to-upper function. I pass it each character of the array, and if it's lowercase, to-upper will return an uppercase version of that, and letter at that location will get modified to uppercase. And if it's a number or an uppercase, it just returns that as it is. Okay. So in place, if I had something like this, let me just, if I enter 1F41, sorry, that's not 1F41, use of to-upper function, and this loop will convert that into 1F41. Okay, that's the purpose of this loop. Okay, now I need to do that procedure where I locate each position starting from the extreme right. Extreme right will be position 0. And first, of course, I convert from character to integer, because every num is a character array. Got to convert to integer. That could be a letter, could be a number as a character. And then multiply powers of 16. Starting from the extreme right, it will be 16 power 0, one before that 16 power 1, and so on. Okay, so largest index I'm going to have will be len minus 2, because don't forget, now we're talking about index, not the size of the array. Index will be one lower than the size. So length was len, last character was slash n, and if I subtract one more, that'll be my largest index. And I need a counter to do the powering. So I run my array backwards. I equal to largest index. That means I showed earlier that if you have one F41, so 0, 1, 2, 3. Largest index will be 3. So when I set I equal to largest index, I'm looking at 1 here. Okay. So maybe I should keep copying then keeping them. I greater than or equal to 0 and I minus minus. Okay, which function do I have? Yeah, that's correct. So that means this loop will exit when I have reached 0 and I try to go one lower than that, like in minus category. So this will run from largest index, let's say 0, 1, 2, 3. First time it will look at this one, then I minus minus will make it 2, then we'll look at this one, then I minus will make it 1, then it'll look at this one, and then I minus will make it 0, and then it'll look at this one. So we go from back to front and look at all the digits. Okay, so what does looking mean? Looking means first we convert each character, and character could be a number but not a numeric value, or a letter. Okay, so we read the first character. In this case we'll read 1, and we store that into a character ch. Okay, notice we are running from back to front, so first time we'll read 1. Okay, so well, that one could be a number character, or it could be a letter character. So imagining that it's a letter character, I mean, it doesn't matter which order you do it. I check that it should be in the uppercase A to the range F. I don't need to check anything else because, well, I'm hoping that they will not enter something funny like Z or anything. I could put code to take care of that as well, of course, but wanted to keep this algorithm simple. So I'm just going to assume in the hex digit they enter A to F. So if it's between A to F range, then I get its integer value on the decimal system. And we explain in the video 3 how this works. This will return the ASCII value. Once we subtract 55, we are going to get the digit value on the decimal. So that could be 10, 11, 12, 13, 14, 15. Okay. But if it's not a, okay, I lost my screen now. Let me just get it back here. I'll keep pasting it. But if it's not a letter like 1 or 4, but in that case, we get the ASCII value and subtract 48, and it just turns out that way. ASCII value of 1 will be 49, so 49 minus 48 is 1, so my digit is in then 1. So I get the digit here if it was A to F, and I get the digit here converted from character if it was 0 to 9. Now then it's easy. My result was set to 0 up front here. I take, and then I run a counter, by the way. Where is my counter? Right here. So counter is 0, and first time I'm going to take the digit, which was 1, and take its ASCII value, that's 49, subtract 48, that becomes 1. So 1 into 16 to the power counter, 16 to the power 0. So first time, I'm just going to show you here what the result will be. First time result is simply it was 1 to the power 6 to the power 0, so first time result is just 1. So I'm going to get that. Okay. Okay. Then next time I'm going to read 4. Okay. Well, 4 is not a digit, not a letter. So this system will convert it to 4. And next time 4, and counter becomes 1, by the way. So it will be 4 into 16. So 4 into 16. That's my next one. Counter becomes 2 now. Don't forget that. And then I'm reading F. Well, this part of the code will convert F to 15, and counter is 2. So this time my result will add 15, sorry, I had to put a plus sign, plus 15 into 16 square, because remember counter was 2. So 16 into 16. And last one is again, not again, last one is 1, and this code will convert 1 to 1 integer, and this time my counter is 3. Okay, I need to go back to the chart I had earlier, sorry. Okay, that's fine. Okay, counter was 0 first. Okay, let me see, counter 0 here, 1 here, 2 here, and 3 here. Okay, fine. So this time I'm going to be adding to result 1 into 16 to the power 3, and that is simply 16 into 16 into 16. Why don't I write it down at the bottom so we can see it a little bit more clearly? Okay, this will work. And counter is now 4, but by then I'd already reached 0 because index here was 3, 2, 1, 0. So I've reached my I equal to 0 actually. But I minus minus will make it minus 1. And minus 1 greater than 0 is false. So I exit my loop. Okay. So we can sum these up here. So it'll be, this will be 64. So we'll have result equal to 1 plus 64 plus 256 into 15. Give me a second. 3480, 3840, sorry, 3840. And last one was 16 to the power 3. So that's 4096. And guys, you can do the math if you want. That should come up to 8001, but let me make sure 1 plus 64 plus 3840 plus 4096. Yeah, comes exactly to 8001. Okay, so I've demoed that code walkthrough for this number that the algorithm gives me 8001 for this number. So let's now run the code and see if that actually happens. So let's run the code. So it says, let's go a little up, hexadecimal number, and on purpose I'll enter lowercase so that you will see that it gets converted to uppercase. And it does. See, 1F41 and result is 8001, which for your convenience we just compute it right here. And you can enter any other number. There are hexadecimal to decimal converters on the web. You can just type on Google hexadecimal to decimal converters or converting calculator. Then you can try other thing. You can type this program, or I have another version of that for my students, and you can run it and you will see, you'll get that result. So for those who want to see all of this program, I may not be able to show all of it, but let's see, what can I do so that if you wanted to type it, you can do it. So what I can do, just do different portions of it and pause. So right here, pause the video, take a picture of the screen with your phone, so you got the main function. Okay, and then from that picture you can type your code. Okay, and then line number 31 to 51 of convert to hexadecimal. Take a picture of this one with your phone or another iPad or screenshot. So you got line 31 to 51. And now take a picture of this part. All the code is showing, comments may not be showing. So you got this part, and finally rest of it. Okay, take a picture of that. So now you have the entire code in pictures. You can type it for yourself and run it and see that it works. For my student, the .c file will be available. Thank you so much. Dr. Singhal from California saying goodbye. Hope you have a great day.